Right, welcome to another video on EDEXCEL A-Level Maths. Year 2 functions, and this is the second video in that series. This is about domain and range, which is section 2.2. Okay, in my previous video, if you learned that domain is the first set of numbers which a mapping transforms into a second set of number, and the second set of number is the range. Okay, so in normal day-to-day mathematical functional language, we say domain is all the values x can have, or all the values of the functions defined for the x values, and range is all the values the y can have or the function can have if the function is y equals fx. Alright, and another thing I would like to share here, in layman's language, I always said in the first video that you got to sketch the graph, it helps. Domain is how wide your graph goes, that from here to here, and range would be how high or low the graph can go. Okay, so if you have the sketch of the graph knowledge secured, you should be able to find domain and range for anything. Okay, we look at some questions now. All right, this is my first example, which I would like you to understand. Fx equals x square, fx equals x square, fx equals x square, and the function is the same in all the three cases, and we need to find the domain and the range. And you would probably say the domain and range would also be same, but that's where the slight change comes. People, have a look what is given for the x values. Because the function permits this x values to have different sets, so that's why the domain will be different, and for that reason range would be different as well. Okay, so domain for the first function here would be what values x can have, what values function is defined on, all real numbers. And here, this one, that's a domain. Here it's this one, that's a domain. Okay, if you want to sketch the graph of this function, guys, you know it's the simplest graph. Okay, for the range now, what is the lowest value the graph can have? We need to see how high or low graph can go, and we can see clearly graph cannot go below 0. Okay, so lowest value is 0. What's the highest value? We don't know, because x can be anything, graph can go as high as it wants. So range is fx is greater than or equal to 0. Right, for this one now we will have to do the same graph, but we're restricted that it should be only from -2 somewhere over here and 3 somewhere over here. That means the sketch of this graph would be only something like this. Right, so domain is given to you, which is between -2 and 3. That's the width of the graph in the sketch, and we're going to now see how high or low graph can go. And this time around, people, on the upper limit, the graph cannot go anything beyond this point because graph is not defined after that point. Let's figure that out. When x equals 3, this is 9. Okay, so range is fx is greater than or equal to 0, where it's minimum point, and less than or equal to 9, that's the highest point. Similarly, you can figure that one out as well. 0 to 7. Okay, so domain is 0 to 7, and range is, guys, 0 and 49. Thank you. That's our first example, the simplest one. I'll come up with a couple more examples now. All right, the first question after that, we do this one, guys. This is something you've learned already, okay, in the first year course, how we draw the graphs of this guy. There's a transformation of functions. So the basic curves is e to the power x, then you do e to the power 3x, then you do twice of e to the power 3x, and then you finally do e to the power 3x minus 1. I would advise all of you to pause the video and sketch the curve yourself. Okay, here you are. This is the graph of e to the power x, crosses y-axis at 1, e to the power 3x, x changes to 3x. Graph should squeeze in, okay, but x values will be divided by 3. So x, which is 0 here, divided by 3, doesn't make any difference, still 0. Graph will just slightly go up slightly quickly. Then it changes to twice of that function. That means every y coordinate will be multiplied by 2. That's why this one changes into 2. Then obviously that's a mistake. You do twice of that function, take away 1. The graph should shift 1 unit down. That's why the asymptote comes down over here. And this value, which is 2 on the y-axis, comes out as 1. Right, guys, we're going to find the range for this because domain is already given to you. And range is how high or low this graph can go. How high this graph can go, we don't know because range is, domain is all axes. So how low, it cannot go below -1. So it is greater than -1. And that's it. Guys, listen, you can't put equals here because graph does not become equal to -1 because x equals minus, y equals minus, x equals -1 is the asymptote to this graph. Okay, let's do the next one now. Draw the graph for me, then we see what the range is. All right, there we are then. These are the graphs, guys. The x squared is the basic function, then it's minus x squared, which is reflected in the x-axis, then it's minus x squared plus 3. It's important, it's better to write the transformations like this. Okay, that's the graph. How high the graph can go is only up to 3. How low, we don't know. In the given form, the range would be less than and equal to 3. Okay, I'm going to show you now, guys, how the range changes if the domain changes for this function, like we did in the previous one. If the domain is only from, let's say, from 0 to 5 or something like this, okay, let's say this 5, so the range will be -3 to 3 minus 25 up to -25. So it should be only between 3 to 25, not -3 and +3. So the graph will be only from, this will be the case of the graph then, and 3 is here and -22. So range in that case will be between -22 and 3. Thank you. We do 2 more questions which are at the bottom. All right, so this is an important graph actually, square root function. If you cannot sketch this graph clearly, and if you do not have a graphical calculator on you, guys, what you should do is you put some values. It says x is greater than or equal to 2. Okay, so that's where 2 comes. When x is equal to 2, it is 2 minus 2, 0. Okay, when x is equal to 1, 3, it will be square root of 1, which is 1. So 3 and 1. When x is equal to 4, it will be square root 2, 5 square root 3, 6 is square root 4, which is 2. So when x is equal to 6, it is square root 2. Okay. Now, really important, people, what you need to see, the graph is coming like this, but when x is equal to 6, it gives you square root of 4, and square root of 4 should give you 2 answers, so it will be -4 as well. So graph is actually a graph like this. Okay, I'm going to ask you a question here, testing the knowledge of the previous things we learned, guys. Is this thing in a given form is a function? And the answer is no. Remember that vertical ray test? If you draw a vertical line, it crosses the graph into 2 parts. Okay, 2 points, that will not be a function. But if it's restricted, people, and we just take the black portion over here, not the red one, then it will be a function if I ignore this. Okay, so what's the range for that function? Then how high it can go, we don't know. As x goes on and on, this function goes up and up. So range would be fx in this case is greater than or equal to 0. Right, and next one is the quadratic equation. I'm expecting you to draw this graph quadratic function yourself, and let's see how do we find range from there. Quadratic functions are slightly easier. Completing square tells us the minimum value or minimum point of that function. You can draw the graph as well. So at x equals 2, y is equal to -3, that's a minimum value. Okay, and as x equals to 0, y is equal to 1. So guys, graph goes like this. Okay, and then obviously it crosses somewhere else as well. Okay, this is the graph, but we're interested in the range of this graph, people. If the domain is not given, that means if domain is all real numbers, the range is anything above this range would be fx is greater than or equal to -3, right? And if this domain was restricted, the range would change. Okay, move on to the next style of questions in here. Now we quickly see how this domain and range works out in the trigonometric function. Step 1, guys, we draw the graph. It says between 0 and 360, so I'll draw the graph between 0 and 360. This is 1 and that's -1. 2 sin x, what happens? Y coordinates will multiply by 2, graph goes slightly higher, that'll be up to 2 and -2. And sine 2x, guys, what happens? The frequency of the graph increases. It's no change in the height, but x, okay. If x is between 0 and 360, the first domain, then range here is fx is equal to, or y is equal, not equal to, between -1 and 1. You see how high or low graph can go. And over here, fx is between -2 and 2, how high or low graph can go. And here it is still the same, between -1 and 1. Okay, let's see how's the effect of this if it changes the domain there, guys. If I say domain is between 0 and 180. Right, have a look. For 0 and 180, what is the graph? Graph is just that top curve for this, guys. So fx in this case will be greater than or equal to 0 and less than or equal to 1. There's no negative portion. 0 and 180, fx will be greater than or equal to 0 and less than or equal to 2. 0 and 180, this is 0 and 180 this time. Can you see? This is 0 and 180. This is here 180. So here the range will still be same. So try and understand very clearly, guys, how your range changes when the domain changes in certain graphs. All right, now let's attempt a question from the book here, people. This is question number 8, exercise 2b, and it says this is a step function and we have to sketch this graph. Can you please try and sketch the graph for the first one over here and second one, both on the same axis? Let's see what do we get. Right, so this is the graph for e to the power x. This is a graph of e to the power minus x, and we're going to do a graph of e to the power minus x, but we need to go only up to 0, and 0 is not included, so I'll put a circle there, and when e to the power 0 becomes 1, so graph will be something like this. Okay, and this will be 1, right? And this is -5. X squared plus 4 should be a graph like this from 0. So it goes up from 4 here, guys, and graph goes like this. Right, now this circle, because x is given equal to 4, this circle here would be filled. So that's the graph sketch for this graph, guys, this question. Let's see what the second part of the question says. Okay, book asked me to find the value of a when PA equals 50. I would first of all find the range of this graph, guys, in the given conditions. The range is when e to the power -5, that becomes e to the power 5. Okay, so somewhere over here, the graph goes up to e to the power 5, but when x to the power 4, the graph goes up to 16. Okay, so range is the lowest value graph can go is 1. So fx or px in this case is not equal to 1, just greater than 1, and less than or equal to e to the power 5. I think that's higher than 16. So this is the range of the graph. Okay, now comes the question, how do we solve when PA equals 50? We're going to see now 50 will be somewhere over here. Does this graph crosses both the lines on this, both the curves, or not? Or we use algebra to work that out, people. So PA equals 50. So we're going to equate both of these to 50 and see what the values of x get. That will be the values of a. Let's use our algebra now. So you figure it out, guys. When we solve this equation with the top function, you get a equals ln of 1 over 50, which will be a negative number something. You can find the calculator, and we know that this graph will meet when x is negative, y equals 50, and x cubed here, actually I was reading it x squared, it was x cubed, so this gives you cube root of 46. That's a positive number, then it's somewhere over here. So these are the two answers for this equation. And your graph can clearly verify this. For this curve, a has to be negative. For this curve, this cubic curve, a has to be positive. Thank you. We've finished this video here. This is about domain and range and exercise 2b practice, and we'll catch you there with the next video. It's composite functions and inverse functions. Bye.